Welcome to the Deep Dive. Today, we are strapping in for what is arguably one of the most essential, maybe challenging deep dives we could do in the world of digital strategy right now.
Definitely. It's a big one.
We're talking about the complete reconstruction of the optimization stack. You know, how SEO is colliding with this huge shift towards generative AI retrieval systems.
Yeah.
Our guide here is an analysis by Dwayne Forrester, who basically argues that the old stack isn't just evolving, it's like fundamentally breaking apart and reforming into something new, something multi-layered.
It's an absolutely critical moment for anyone, really, who deals with content visibility. We need this kind of detailed look because the core conflict, it runs deep, doesn't it? For, 2 decades, we've optimized for systems designed to rank pages using algorithms, deterministic ones.
Right. Predictable, mostly.
And now we're facing systems like Perplexity, Gemini, ChatGPT. These are designed to reason with content. They synthesize answers. They don't just list links.
And that idea of reasoning, that changes everything. Where we put information, how we prepare it, why we even bother. The source material frames this really well, I think. It's not like we're tearing everything down. It's more like an advanced syllabus.
That's a great way to put it.
We're moving from, say, high school, where we learn the fundamentals, the technical basics of the web, to university.
Yeah.
Where advanced discovery, semantic processing, machine trust, those are the core subjects now.
Yeah, the advanced stuff.
So our mission today is basically to give you that comprehensive syllabus. What does visibility even mean in this new hybrid sort of advanced era?
Okay, let's enroll. Let's jump in.
Really?
So before we can even get into these 5 new layers of optimization, we have to get the concept straight. We really need to understand the difference between the old engine, the algorithm, and this new engine, the model. It's fundamental.
Okay. So algorithms,
Okay.
these are the linear systems we kind of grew up with in SEO,
Yes.
right? At their heart, they're fixed path problem solvers. Like a really complex recipe, maybe.
Yeah, that's a good analogy. Start at A, process through B, evaluate factors, C, D, E, and boom, result X. The key thing is they're deterministic.
Deterministic, meaning rigid, transparent,
Right.
reproducible, crucially.
Exactly. If you feed PageRank or the old crawl scheduling rules, the same inputs today, tomorrow, next week,
Yeah,
you get the same result.
always.
They execute a precise set of instructions. They decide what to rank based on rules we mostly figured out over time. They're predictable.
And that predictability, that was the entire basis of traditional SEO. We focused on decoding those rules. Okay, so now let's pivot. The new system models,
Yeah.
specifically large language models. This is where that linear path just collapses. And we're in some kind of multidimensional probabilistic space.
That's it, exactly. What's really fascinating is that a model performs spatial problem solving. It's not following a single path. Instead, it's balancing millions, maybe billions, of learned weights all at once across this vast invisible coordinate system.
Like a map of meaning.
Sort of, yeah. The model explores this landscape of probabilities and tries to find the most likely statistically relevant outcome based on all the data it's seen.
So, if the algorithm is following that strict recipe, the model is more like a really experienced chef.
Ooh, I like that.
Someone who's internalized millions of past meals, ingredient behaviors, preferences, and they're improvising the best dish for right now.
That's a great way to think about it. The result is probabilistic, flexible, adaptive, sometimes, yeah, surprisingly creative.
But that's also where the challenges come in for optimization, isn't it? The trade-offs.
Absolutely. Algorithms were, relatively explainable. Models are often opaque, the black box problem.
Right.
And what's more, they're prone to subtle changes, drift. Their internal weights can shift based on new data and new reinforcement learning, and the operator might not have even changed a specific rule.
So the distinction is key. An algorithm decides what to rank based on fixed rules. A model decides what things mean based on inferred relationships.
Yes. It infers relevance, it infers truth, it doesn't just execute a ranking calculation.
Okay, so this explains why that common phrase you hear, the AI changed its algorithm, is kind of missing the point.
Completely misleading. They're missing the fundamental leap. The system didn't just tweak a formula.
It actually evolved its internal understanding of the world.
Precisely. It adjusted those millions of learned weights. It effectively changed its interpretation of relevance and authority. The whole landscape shifted internally.
Wow. Okay, that makes the optimization task exponentially harder. If we're optimizing for a fixed algorithm, we chase rules. We can do that.
Yeah.
But if we're optimizing for a probabilistic model that's constantly adapting its internal understanding, we're chasing a moving target. And it's defined not by clear rules, but by things like semantic coherence and context.
That's the challenge.
So what's the operational implication for content creators, for businesses?
It means we have to shift our focus. We can't just engineer for a precise set of factors for one system anymore. We need to engineer content that's robust enough to be consistently understood across multiple independent interpretation systems. You've got retrieval, then reasoning, then response.
Yeah.
Each governed by these shifting probabilistic rules.
So the goal is content that's just inherently meaningful,
Sure.
regardless of the model's internal state at that exact moment.
That's the ideal, yeah. Build for meaning, build for clarity, build for structure.
Okay, so let's get into the layers. We have to start with the fundamentals, right? If this new optimization framework is the university curriculum, layer 1 is your mandatory high school diploma. You just can't get into the advanced courses without it.
Absolutely. And look, this is the section we need to cover, maybe a bit quickly, not because it's unimportant, it's the absolute non-negotiable prerequisite, but because it's the most familiar ground for many people.
Right. Things we've known for years.
Yeah. The foundation built over the last 20 years, it still acts as the gatekeeper. And the source warns, pretty clearly, skipping this base means you're absolutely building on sand.
Can't build anything lasting on sand. So
Yeah.
what are we talking about? The
Yeah.
basics that just have to be perfect.
Clean, logical site architecture, robust, well-managed internal linking guiding the bots, making sure all your important content is technically crawlable, proper use of structured data like schema, sensible URL structures, and yes, still, site speed matters. These are the mechanical requirements. Eligibility 101.
Right. So this covers Google's first 2 stages, basically. Crawling and indexing.
Exactly. Crawling, the bots discover your pages. Indexing, the engine analyzes and stores that information for potential future use. And the critical point here is the index. If you're not in the index, for whatever reason, you simply do not exist in this entire optimization stack. Game over before it starts.
And the ways you can fail here, they're often simple mistakes, but the impact is catastrophic.
Deceptively simple, yeah. A misplaced robots.txt directive blocking key sections, accidentally using no index on essential pages.
Canonical tag problems.
Broken canonical signals, complex pagination that just confuses the crawler. These are all ways to completely take yourself out of the running at layer 1.
So it's really the essential eligibility check.
It is, and we still see it. Highly technical sites trying to do advanced vector optimization, but they've got a canonical loop somewhere, or indexation traps blocking their best stuff from ever being seen by the system.
You've got to audit your crawl health constantly.
You must. If the machine cannot mechanically read your data, all the fancy semantic refinement in the world is just useless.
That's the key takeaway for this foundation, then. Visibility starts with eligibility. Earn that high school diploma before you even think about stepping onto the advanced campus of AI discovery.
Couldn't say it better myself. Get the basics right first.
Okay.
Okay, now we get into the really new stuff. The heart of the new optimization stack, the university core. Once layer 1 ensures the machine can actually read your content, layer 2 is where we teach the machine what your content means.
Layer 2, vector and retrieval. Okay, so this is where the optimization target makes that fundamental shift, away from just keywords towards meaning, context, and these machine-readable things called embeddings.
Exactly. We're moving beyond simple text matching. Let's break down how this works, because it's pretty different. Vector search is basically the engine of layer 2. We take content, could be a word, a paragraph, a whole concept, and turn it into this high-dimensional numeric representation. An embedding.
Okay.
Think of it like assigning coordinates on a huge invisible map. And on this map, proximity equals semantic similarity. Closeness means related meaning.
Gotcha. So an old keyword system might see feline and house cat as totally separate strings of letters.
Right. Far apart.
But in this vector space, their embeddings would be sitting almost right next to each other, because they mean basically the same thing.
Precisely. They share the same fundamental meaning. So vector search finds content not by matching exact letters, but by finding things that are close together in this semantic space.
Okay, that makes sense. And this capability, this vector search, is what drives retrieval.
Yes. Retrieval is the process where the AI system rapidly identifies a candidate set of content chunks, little pieces of information that seem semantically relevant to whatever the user asked.
Candidate set, okay.
But it's not just pure vector magic, usually. Modern systems, the good ones, rely on a more sophisticated hybrid retrieval strategy.
Hybrid. Okay, that sounds important. Why hybrid?
It's essential for balancing accuracy and recall finding the right stuff without missing too much. The source material cites the use of both semantic embeddings and BM25, along with something called reciprocal rank fusion.
Right. Okay, let's unpack those. BM25 and reciprocal rank fusion. RRF. These sound central to this new stack.
They really are. Let's start with BM25. BM25, Best Match 25, is basically the modern evolution of older keyword frequency measures, like TF-IDF, if people remember that.
Vaguely.
It's an algorithm that assesses how relevant a document is based on how often the search terms appear in it, but it's smart enough to penalize really long documents and common words, stop words. It's essentially the refined keyword signal.
Okay, so BM25 handles the traditional keyword relevance, making sure we still match the specific words the user typed.
Correct. It anchors the search in the query's vocabulary. Meanwhile, the semantic embeddings cover the deeper meaning, the context.
Got it. Keywords and meaning.
Then, hybrid retrieval uses reciprocal rank fusion, or RRF, which is a really clever way to blend the scores from both systems, from BM25, keyword relevance, and vector search, semantic relevance.
How does RRF blend them?
It basically looks at the rank position of a document in each list, the BM25 list and the vector list, and gives more weight to documents that rank highly in both. It smooths things out and ensures that something strongly relevant on both keyword and meaning gets a big boost.
Okay. So it surfaces the consensus best results.
Leading to a much more accurate candidate set.
Hmm.
And the evidence for this hybrid approach is, well, it's stunning.
The Anthropic research that Forrester cited.
Yeah. It showed that combining these contextual embeddings and contextual BM25 dropped the failure rate for finding the right information in the top 20 chunks by nearly half.
Nearly half. What were the numbers?
It went from about 5.7% failure rate down to 2.9%. That's roughly a 49% improvement in retrieval accuracy. That's not incremental. That's a paradigm shift in the machine's ability to find the right piece of information.
Wow. Okay. That kind of improvement explains why this is layer 2. It changes everything downstream.
It really does. And it leads directly to the core actionable strategy for layer 2, modular content.
Right. We have to stop thinking about content as just like big, long articles designed purely for human reading flow.
And start treating them as data chunks.
Data chunks. Explain that.
For the retrieval system, a 2,000-word article is often too big, too cumbersome. It might contain multiple ideas. A chunk, maybe a single paragraph or a precise list, or a definition that addresses one single coherent idea, is highly efficient for the machine.
Easier to embed, easier to compare.
Exactly. So optimization for retrieval means breaking down your large topics into these well-defined segments, each one tagged, structured, so it can be easily embedded and compared against millions of other chunks.
And the goal isn't page 1 ranking anymore.
Not primarily for retrieval, no. The goal is ensuring your specific, authoritative chunk gets selected for that candidate set, being in the pool of options the AI will consider.
Okay, that sets the stage perfectly for layer 3, the culmination of this university core. Layer 3, reasoning. So retrieval gathered the most relevant pieces, the candidates. Now, the reasoning model takes that pool and decides what, if they're true, if they're usable.
Both and more. The reasoning function is really complex. It assesses the candidate content for coherence, does it make sense together? For overall validity, is this information credible? For immediate relevance to the specific query nuance, and maybe most importantly, trust.
Trust. Okay, this sounds like it goes way beyond the old EAT concept expertise, authoritativeness, trustworthiness that we used to talk about.
It does. It's machine trust. Authority in this context means the machine has to feel confident reasoning with your content, treating it as reliable evidence when it synthesizes its final answer for the user.
So the model is basically asking itself, can I stake my AI reputation on this fact being correct?
That's a very good way to put it. Can I use this piece of information without looking stupid or wrong?
Okay, so how on earth do we optimize for that, for layer 3, for machine trust?
The strategy has to be designed entirely for machine validation and structural consistency. We have to design for machine trust.
Meaning?
Making sure all claims are easily verifiable, linking out to authoritative sources, ensuring your metadata is clean, consistent, accurate, enforcing clear and consistent attribution and citation practices within your content.
So the reasoning model isn't just reading the words, it's reading the structure.
Yeah.
the relationship between facts.
Absolutely. If you claim X, do you immediately cite source Y? Is source Y itself credible, well-linked, recognized? Is the author clearly identified and associated with expertise in this area?
Uh-huh.
The model interprets structural consistency, things like using schema markup correctly, consistent internal and external cross-references, clear author identity. These are vital proof signals.
Proof signals, I like that.
If your information architecture is sloppy, if your citations are missing or inconsistent, if you use vague, unproven language, the reasoning model will likely downgrade your content's reliability, even if Layer 2 found it semantically relevant. You fail the trust test.
The burden on content producers here seems massive.
Yeah.
This demands a level of almost journalistic rigor. Data integrity, things that weren't strictly mandatory for just ranking for keywords.
It's a higher bar,
Like-
much higher. You need accuracy, clarity, and structure.
Okay, so we've passed the high school basics, layer 1. We mastered the university core of meaning and trust, layers 2 and 3. Now we get into the advanced disciplines. Layer 4, the response phase. This is where visibility undergoes maybe its most radical transformation yet.
I think so, because in the past, the goal was simple. Get the click, the blue link click.
Right, traffic.
Now, the senior year goal, let's say, is to be the source of the model's actual answer. Visibility now means your content being included in the final synthesized answer sets that the AI generates and gives directly to the user.
Okay, and this immediately brings up that huge challenge. Attribution.
And the economics of it all.
The attribution challenge, yeah.
If my perfectly optimized modular chunk of content powers the definitive answer from an AI assistant, I've achieved visibility, technically, but I might not get a single click back to my site.
That's the reality we're facing. You
Yeah.
become an authoritative participant in the answer chain, but potentially without that immediate traffic benefit we've always relied on.
So this is where Forrester's strategic reframe comes in. The new mantra is shifting from rank me to use me.
Exactly. We're optimizing for participation in the answer, not just for position on a results page.
But let's push back on that for a second. If you're a major publisher or an e-commerce site and suddenly 70, 80, 90% of your informational query traffic disappears because it's answered directly by the AI, how do you survive financially? Does this framework offer a new way to monetize, or is it just fundamentally breaking the existing business model of the ad-supported internet? That is the multi-billion-dollar question, isn't it? The framework doesn't explicitly offer a monetization path, but it implies where the value must shift.
Okay.
If the click diminishes, the value has to move towards things like citation impact and brand presence within the AI's response. It's about being recognized as the authority, even without the direct click.
So the source suggests we need to optimize explicitly for machine attribution, making it easy for the AI to credit us.
Yes. How do we achieve that technical attribution? That's the key question for Layer 4.
And the answer is?
It requires deep, granular use of specific machine-consumable schema types, markup that perfectly aligns with the entities, the people, places, concepts, products that you're talking about.
So really doubling down on structured data.
Absolutely. Reinforcing clear author and entity identity across your entire site, not just for human readers, but so the machine can accurately cite who said what, and crucially, providing explicit, well-structured citations within the content itself, making it trivially easy for the model to identify and credit your source material when it borrows your facts.
Okay, so let's take an example. If I have product review content,
Yeah.
I need to make sure my product schema, my review schema, the aggregator rating, it all has to be structured so cleanly that the model can just pull that data directly and reference my brand or site, even if it summarizes the review in its own voice.
That's precisely the goal. And it applies to commercial schema too, like how-to guides or FAQ blocks. Don't just treat them as static text. Structure them as data explicitly designed for AI reuse. Your aim is to maximize the chance that the AI, when building its response, selects your content as the primary citable evidence.
So you establish your authority, you get that brand mention, you drive that long-term value, even if the short-term click goes away.
That's the strategic play for Layer 4. Accept the shift, optimize for attribution.
Okay, that brings us to the final layer, layer 5. And this one feels maybe the most mysterious, the reinforcement loop.
It is a bit opaque, yeah. This is the continuous learning phase. And the argument is this has essentially replaced traditional off-page optimization like link building was.
How so?
This is the feedback system. It's how the whole stack teaches itself to get better over time. Retrieval systems learn which candidate chunks were actually useful in generating good answers.
Okay.
Reasoning models refine their internal understanding of trust based on which sources proved reliable, and the response models update based on user behavior after seeing the generated answer.
Right. And specifically for the response models, they're constantly updated using reinforcement learning from human feedback, RLHF. Can you explain RLHF simply for someone who's not technical?
Sure. Think of RLHF like the model is constantly doing its homework,
Okay.
and then humans, sometimes specialized contractors, sometimes just based on general user activity signals, give it grades.
Like ABC.
Pretty much. The AI generates an answer. Humans, or proxy signals from users, rate it based on accuracy, helpfulness, safety, tone, whatever criteria are important. This feedback loop is then used to fine-tune those millions of internal weights again, teaching the model what a good answer looks like and, crucially, which sources tended to lead to those good answers. Ah, okay. So the sources that contribute to highly rated answers get implicitly boosted.
That's the core idea. Positive performance reinforces perceived authority.
Which means the metrics we need to track are fundamentally new. We're not just looking at rank position and click-through rates anymore.
Exactly. The new signals, the behavioral reinforcement signals, are things like how often is a specific content chunk successfully retrieved by the system? How frequently is it actually included in a final, well-received answer?
Or maybe, do users engage positively with the AI assistant's response when it uses my content? Like, do they thumbs up it or not immediately rephrase the query?
Those are exactly the kinds of signals. It's
Yeah.
critical to grasp this. If your content performs well in that response layer, if it gets reused, cited correctly, and leads to positive user feedback, that success feeds back positively into the model's ongoing understanding of your authority and relevance for future similar queries. Okay, but here's the practical problem. If these systems are often closed boxes, if the retrieval counts, the inclusion rates, the RLHF scores are happening inside a proprietary model like Gemini or ChatGPT, how can the average content creator possibly track these signals and optimize for layer 5 effectively? We can't see inside their logs.
That is the major practical roadblock right now. It's a huge challenge. While we can't see the internal logs directly, we have to look for proxy signals.
Like what?
Well, we can try to track citation inclusion using specialized monitoring tools that scrape AI answers, or maybe look at Search Console reports showing increases in zero-click answers for certain query types, implying AI responses are handling them.
Okay, indirect clues.
But more importantly, maybe more actionably, we have to optimize the content itself to be inherently successful when it gets reused, even if we can't measure it perfectly.
Meaning, the advice for layer 5 is create content that is highly reusable. Design it explicitly for positive user engagement, even when presented by an AI, and structure it for seamless recontextualization by the machine.
Exactly. If the machine can easily break your content apart, understand each piece clearly, and reassemble it into a useful, concise, accurate answer without introducing errors or ambiguity, you're feeding that reinforcement loop positively. You're making your content perform well inside the AI.
But conversely, if your content is messy, confusing, maybe internally contradictory, or just poorly structured,
The model might retrieve it once, struggle to reason with it reliably, generate a poor answer, get negative feedback, and then learn to ignore your content in the future. You effectively vanish from the machine's long-term consideration set for that topic.
so poor structure and clarity in layer 3 can lead to negative reinforcement in layer 5. It's all connected.
The whole stack is interconnected. Performance at each layer influences the next. So if we try to synthesize everything we've talked about, from layer 1 all the way to layer 5, the strategic conclusion feels, well, undeniable. You're not just optimizing a static website for a single predictable algorithm anymore.
No. It sounds like you're optimizing a complex, dynamic, multi-layered stack for a probabilistic, constantly learning model, or rather multiple models working together.
That's it. And the current moment demands this hybrid strategy, doesn't it? You absolutely cannot abandon the high school fundamentals of the old ranking system, the crawlability, the indexing, because without layer 1, you're not even eligible to play.
Right. Can't skip the basics.
But at the same time, you have to prioritize the university core. You need to be building aggressively for these new reasoning and retrieval systems. Layers 2 and 3 are critical now.
Okay, so let's give the listener that clear checklist again. The syllabus for this advanced course in visibility, mapping directly to the 5 layers.
Sounds good. Where do we start?
First, the foundation. Layer 1. Ensure absolute crawl access. Maintain pristine index status health. Fix all those basic technical SEO issues. Eligibility is step 0, non-negotiable.
Second, focus on retrieval. Layer 2. Modularize your content, like aggressively. Break it down into defined, coherent data chunks. Optimize those chunks for semantic meaning using that hybrid approach keywords plus vector embeddings. Aim to get into the candidate set.
Third, structure for reasoning. Layer 3. Implement robust, accurate schema markup. Ensure clear attribution for claims and authors. Build structural consistency throughout your content so the machine sees it as trustworthy, verifiable evidence. Build for machine trust.
Fourth, design for the response. Layer 4. Shift your goal from just rank me to use me. Optimize for answer participation and reuse. Focus on becoming the authoritative, citable source for the AI, understanding that direct clicks might decrease, but machine attribution is the new currency.
And finally, fifth, track those feedback loops. Layer 5. Look for those proxy signals of behavioral reinforcement. Monitor retrieval rates if you can. Track citations or inclusion in AI answers. Most importantly, design your content to perform well, to be reusable, and generate positive engagement signals within those assistant platforms. Feed the loop positively.
You know, I think the most important takeaway here is that this increasing complexity, it doesn't signal the end of SEO or visibility strategy, not at all.
No, it signals its advancement, right?
Exactly. The old skills, maybe focusing just on link building or keyword density, they're insufficient now. But the core discipline, understanding how discovery engines work and communicating effectively to them, that's actually more valuable than ever before, it's just harder.
We've watched the entire focus shift. From deterministic algorithms that cared a lot about site speed and link authority, to these probabilistic models that prioritize semantic meaning and, crucially, machine trust. It's a huge change in what matters most.
Indeed. We've moved fundamentally from optimizing text, primarily for an algorithm to read, to optimizing structured data for a model to reason with.
So as we wrap up this pretty massive deep dive, let's circle back to that provocative final thought from the source material. If the web we originally built for humans is now being systematically reinterpreted for machines, if we are strategically designing content primarily for machine consumption, for its modularity, its verifiability, its reuse by an AI assistant, what are the long-term implications? Ethically, practically, for content creation itself?
Yeah.
Are we ultimately serving two masters, the machine and the human end user?
Well,
Or is this machine-based optimization target rapidly becoming the dominant priority? Could that lead to content that's like structurally perfect for AI reasoning, but maybe less engaging, less nuanced, less human for the actual reader who eventually sees the output?
that tension right there, the potential gap between optimizing for machine trust and structure versus optimizing for human experience and engagement, that feels like it will define where the true value of content creation lies over the next, say, 5 years.
It's the core challenge, isn't it?
It's the challenge every content strategist, every creator, every business leader needs to be grappling with right now. Where do you place your bets? How do you balance those potentially competing demands?
That is definitely the complex thought for you, the listener, to mull over as you start applying these advanced disciplines of visibility we've discussed. You now have the full syllabus for the advanced course.
You're prepared to navigate this hybrid era, or at least you know what you need to learn.
Thank you for joining us on this deep dive.